What is crack-a-lackin', people? Long time no see. I am glad I'm back here right now. Yeah, but we've had some pretty big explosions here, guys. On the backside, Earth definitely did dodge a bullet. And I'm going to show it to you here really, really quick. I mean, two huge filaments. Okay, massive filaments on the backside. One, we've been talking about the polar eruptions, right? Because that does point to the pole reversal on the sun, which is the sun cycle, right? So what I'm saying here, guys, two big ones on the polar regions. It looks as though the whole backside of the sun is very active right now. So with that happening, we're going to have to watch here in the next week or two to see what's going on. Because this is definitely something we need to pay attention to. All right, I'm going to start here, guys. I'm not going to make you guys wait to see this, okay? Because this is some pretty massive eruptions. I was actually fairly surprised. And I was looking at the CME trackers, one of the NASA models, one of the NOAA models. Now, typically they don't always 100% line up. But this time, it looks as though they're like in complete disagreement. So, and I'm kind of leaning towards the NASA model right now. And the reason why, and I'll show you, because these are clearly on the backside. And the NOAA model seems as though it's showing something coming off the front. Now, that, when you get these polar eruptions, it can actually confuse these models. Okay? So if it's coming off the north or south, sometimes it can't understand if it's going away from us or towards us. And I'm sure NOAA will actually, because this just happened a few hours ago, a couple times anyway. So with that being said, I'm sure NOAA will come out and, correct the model, because that's what they do, right? You got to understand, this is Monday morning. Those guys get the weekend off too. Just saying. So I'd look for some of these things. It's like seeds. Seeds has been down now for over a week. I haven't really looked much into it to see why. My guess is it's some sort of maintenance or what have you. Or they could be having technical issues, or, I don't know why. But everything else is up and running. We can still see the same information on other websites. So there ain't nothing crazy going on with missing data. The data's still there. We can still go look at it. And I'm going to show it to you. Don't let somebody say, oh my God, Seeds has got this down for a week or whatever, and we can't see nothing. They're hiding this, they're hiding that. No, that ain't what's going on here, guys, because I'm going to show you the same data. Okay, so, but anyway, let's go ahead and just hop into this. I got you over here at ISWA, and what we're looking at, guys, this is the SDO. The SDO sits out in front of Earth, right? And it's in geosynchronistic orbit. What that means is it's over the same part of our planet at all times. And as it rotates around our axis with us, right? But it does this figure 8 pattern. So it stays basically over the Eastern Pacific. Okay? And what I mean by that, it kind of goes up towards California, and it does a big, like, stretched out figure 8. And it goes south. That's just how it does. Now, they did that for a lot of reasons. One of the reasons being, it gives us the better chance of more view of the sun. Because it's in geosynchronistic orbit, it needs to be in a position to where it's always looking at the sun, right? So with that being said, the Earth actually does get in front of the satellite, or the better way to say it would be between the satellite and the sun. Because the satellite always keeps its eye on the sun. Much like Lord of the Rings eyes, I don't know if anybody's ever seen that movie. I'm sure a lot of you probably have. It's a very popular one. But, the big great eye, it's on the big tower, and it always is looking for the ring. Well, this one's always looking for the sun. So, I guess you could say the sun is my precious for the SDO satellite. But anyway, so let's go ahead and take a look at this. Now, this is the 304 angstrom. This is the ionized helium. And, this gives us a different look at the gases that are on the sun. That's why we look at this. They could assign this any color they wanted. And I've said this so many times, but I do want to, keep saying that, at least at the beginning here, because, there are people that are getting into this that don't know nothing about it. And with us going into, being in solar maximum and those kinds of things, and the pole reversal getting ready to happen and all that on the sun, I look to see some newer viewers, popping in because, they're just curious. So, oh, and briefly, before I move on with that, guys, listen, I want to go back to using my old intro, the music anyway, right? I've used that music for years, but that song is actually copyrighted now. I actually paid for that song a long time ago. But for some reason it's not noticing that in the system. Now it doesn't like give me any kind of strike or anything like that. It just limits how far out it goes, where they recommend my video at. It'll turn yellow in my analytics. That's what that means. Okay? And it's not going to affect anything else other than that. But I want to be able to get this stuff out to everybody I can to talk. That's why I'm here, right? So, with that being said, that's why. I just want to give you a brief explanation on why I'm not using that right now. I'm still trying to figure out if I got to go back in and get the license from it, and that way I'll be able to do it, and all the above, right? So let's just go ahead and jump into this. Okay, like I said, I got you here at ISWA, and what we're looking at, guys, is the 304, like I said before, and I'm going to show you the other angstroms also. But let me go ahead and we'll go ahead and run this one a little bit, okay? And you're going to see, I guess I should start here at the top, because that's when the first eruption happens. Watch right up here. I'm actually going to zoom in for you guys, okay? See that? That is a massive filament release. Now, that's not completely on the backside, okay? This is why the models, I think, are having some issues. You can see where that filament, and let me go ahead and zoom in here, because this does have a chance, even though this is like, this one here especially, has got a chance of giving us some, a little bit of a hit. I don't look for this to be like a direct hit. So watch what I'm saying here. You're going to see this filament stretched out right here, and it's going to be on the front and the back. Look at it lifting off. Look at that huge thing. You see that? Now, it does look to be mainly on the back. Okay? So, regardless, it does look like the way that it did flick out like that, the majority of it's going to go north anyway of Earth. Okay? That's what I would say for just about any polar eruption. But you can see how we got lots of filaments just laying here on, in the corona now. Some of these things, a lot of these will lay almost right on the surface. So when you start seeing these filaments starting to kind of raise up, we take notice, because that means they're becoming unstable. And as they lift off, they'll bust just like an incandescent light bulb filament. Any of you guys that are over the age of 30 probably remembers what an incandescent light bulb is. And I've talked about that before. But that's what it does. It causes resistance inside that light bulb, and that's what gives it the light, creates heat, right? So that's exactly what's going on here. We got plasma traveling on these magnetic connection lines. So that is not a flare. I want to point that out straight up. Okay, this is not a flare. There is no flare related to this at all. And that's important to know, because there's no X-ray. There's no increased X-ray. What this is it's highly charged particles. It's plasma, charged gas. And yes, that's an issue for us when it does hit. Okay? So when we get a flare on the front side, we get both typically, right? We'll get a big flare, we get the blast of X-ray, and sometimes even a blast of protons, which is a radiation storm. But then a day, two, sometimes mainly between 2 to 4 days is kind of normal. We would see the CME hit, which would be the plasma. And that, even though I'm calling this a filament, it's still a CME. It's erupting out. It's an ICME, interplanetary coronal mass ejection. Okay, because it ejected out. Essentially, that's what it is. Now, if you get like just the singular, eruption site, that is really the CME part. Okay, these are filaments. These are technically filaments. So I just wanted to point that out. So that is a big one, right? So let's go down here and check out the other one. Guys, I'm literally, this is north and south pole of the sun erupting almost at the same time. The one on the north went off a little bit before. Now, you see all that? I mean, come on. If that thing was coming right at us, I'm just saying. I mean, I'm not trying to, and I'm not, you'll never hear me come out here and be fearful, because I'm not at all. This stuff does not scare me, even when it's coming right at me. But I will be realistic with you guys. If those kinds of things come right at us, that could give us issues. It's got a very strong possibility of giving us at least some issue. All of us might not see it, but that right there, guys, is one of the biggest visual eruptions I've seen in a very, very long time. Now, I'm going to show you a few other filaments and stuff that are hanging out, getting ready to erupt probably here in just a few hours. Well, I can't say that for sure. Sometimes they kind of stabilize back. But this is what we oftentimes see. We see the eruptions at the top or somewhere on the sun, and it'll destabilize the whole area of the sun. In this case, the backside. Okay, so the whole backside of the sun is, in my opinion, probably a little bit unstable right now. We could look at the helioseismographs, those kinds of things. Those, yes, earthquakes or seismic activity on the sun. I don't want to call them earthquakes because there's no earth on the sun. It's seismic activity on the sun. And they're able to map out and give us some sort of a visual what the backside looks like using that seismic data. And it's getting more and more accurate. We don't have a whole lot of satellites back there able to see the backside of the sun. And there's a lot of reasons for that, because sometimes the satellites, first off, you're not going to get a real-time or even close to real-time imaging from the backside of the sun, because the satellite has to be over there to see it, right? So in order to transmit the data back to Earth, it's got to move itself away from the sun. Catching what I'm saying there? So it's not as easy as people want to say, oh my God, why can't we see we do see the backside of the sun. We do. Just we can't get the real time stuff. And I'm sure there's some big technical stuff they could do to get the data on one satellite, transmit it to another, and get it back to Earth, right? Yeah, that probably would work. They may even do that. I don't really know. But at the same time, it's still not going to be very fast. And I would say that they would lose a lot of the accuracy the more times they ping that off any kind of other satellite. That stuff's traveling through the air. It's traveling. The data has to travel to the other satellite, and sometimes that'll affect it. Just think about your own Wi-Fi in your house. Same kind of thing. Okay? When you got more things running, what happens? It slows it down. And sometimes you got to let the data go a little bit. You got to let the resolution go so you can even get a proper picture. So I'm going to zoom back out here because I do want to show you guys the whole picture here. Okay? So I'm going to just grab the slider here. Okay, so watch the top. Watch up here. Okay? That in itself, that is a significant filament release. And remember, we're not seeing the whole thing here. Some of the stuff's it's on the backside where we can't see it. So remember back, I think was it 2017 or 2019? It might have been, I can't remember. I don't want to say the wrong day here, but we had a big one. I think it was in September. I think it was 2017. It might have been 2019. I'll go back and I'll look. I can't remember. For whatever reason, I'm drawing a blank on that right now. But we had one that they actually upgraded, because they've actually upgraded the top 39 eruptions on the sun. They went, using the newer technology, they were able to say, and they've increased that particular eruption a lot bigger than what they initially thought it was. Okay, so the one that missed us by 12 hours, right? Yeah, that one would have given us issues probably 1,000%. Okay, and there's no doubt about it. It was one of the bigger eruptions of the whole solar cycle in a very long time, and it didn't miss us by much. Okay, Matter of fact, if I remember right, it even gave us a radiation storm. And, you know, again, when it's firing off the backside, especially when it's on what we call the west side, that would be the right when you're looking at these images. Yeah, sometimes those protons will get drugged back through, and I've explained how that happens. Maybe I'll leave a link or something in the at the end of the video here, to where, or point you to a video to where you guys can go see where I talk about that. But anyway, that filament erupted up top, and then check this out. Wham! I mean, guys, notice, and here's another thing. I want to say this. When these things, bigger eruptions happen, like this one down here, if it was erupted right here, we wouldn't be able to see it as well. The sun is the background in that case. Well, the darkness of space is the background here. That's why we get a really good visual of this. But I do want to point out, that is a lot of plasma there. It's very dense. You can see it. Okay? I mean, it is just, yeah, it's a lot. Okay? So yeah, and again, we're going to have anything coming at us. These models are a little bit conflicted right now. And so let me show you what I'm talking about here in just a second. But I do want to show you this one too. This is a really good way to show you guys how the things travel on a magnetic connection line, because that's exactly what you're seeing there. Let me this here. Okay, so let me grab the slider here. You see how it appears to be like spinning or twirling? See that? You guys can see clearly that's the plasma moving on a magnetic connection line. Okay? It's not wind. All right? It's not wind like you come out here and you see a tornado in the Midwest. That's not what that is. Okay? I'm talking about this over here, not this big one right now. But yeah, check that out. This is a really good way to show you guys. Now, if that thing was destabilized, that could pop off too. But it looks to be like, you know, a lot of that's going right back to the sun. You see this other line right here? That's typically what we see, right? But it does seem to be standing up there a good distance. Okay, so if it, you know, would it be a big deal? I can't say for sure. I don't know that it would. I don't think it would, especially the location of it. You know, it could erupt our direction. We would probably see a little bit from it if it did. But I don't think anything like SHTF type of stuff would happen. But these right here, I was trying to figure out if any of this was on the front side of the sun. It's not. All that's coming off the back. Okay? Well, let me rephrase that. It's almost going directly south there. Okay? At least that's what it appears to be, at least in my opinion. So, right. I mean, look at all that, guys. I mean, that's just a lot. And it's almost like two separate filaments there are kind of spread out a little bit. Okay. So, yeah. Let's, okay. So, let me go ahead and move forward here, guys. I don't want to waste your guys' time. And I know I haven't been here for a minute, but I'm not even going to go into what's been going on with me. It's just been so much stuff going on. It's too much to even, you guys don't want to hear that stuff anyway. So, that's one thing I'm going to work on in the future, is I don't want to be bringing my negativity out here. And that's one of the reasons why I didn't do a video past week and a half. Because my mind was in such a negative spot because of everything that was going on in my own personal life. I would have brought it out here and you guys would have sensed it and you guys would have been worried about me, and because you guys always are, which is awesome. I do appreciate that. But that's why. That's the explanation. I'm not going to go into detail, but that's what's been going on with me. Okay? And right now, my daughter is actually on what they call fall break. So she's got a week off. So I should be able to, at least this week, really give you guys some content. Okay? So please come back. I'm going to be trying to upload more. But I do think I can at least give you guys, at least this week, one every day. It may not be a long one, but, you know, I'm going to give you something here. And I do apologize for the ones that I don't speak on. And again, that negativity comes in there to play a little bit, but mainly that's because I'm in a actual physical space where I can't get to my computer and I have to use my phone. So I don't like to, be using my phone and trying to, voice over stuff and things like that. It really does suck. That's what I'll just say. So this is the 131. I'm not going to waste too much time on this one because you're just not going to see much. And that's why this is a different gas. That's why you're not seeing it. Okay. So let me, do that. Let me scroll down here. This is the 94, and we do see, like when the eruptions happen, we do see really bright eruptions on the 94 angstrom. So it doesn't pick up filaments all that great. What I will say is this. You guys see this area? Okay. That area is, I'm going to be watching that area. That's all I can say. You can see where here at the end, even back here on the backside, it looks like it might be erupting again. So, yeah. It doesn't, and that's the thing, guys. It's not even picking up that southern eruption. It's not picking up these filaments hardly at all. And it's probably not meant to, okay? It's a different gas. Now, the 211, see, we got coronal holes too, guys. And we actually got a geomagnetic storm a couple days ago. I think it was from a small CME impact. And they didn't know it was coming, I don't think, because none of the models showed it. So that's what I'll say. Their prediction models didn't. And it could have been a coronal hole stream too. Sometimes these coronal holes will fool you. Right? So this is the 211. Yeah. And you're not seeing much on that either. But I do know that you're going to see a little bit of coronal activity on the 171. Okay, if you want to see the corona, this is probably one of the better angstroms of light. Okay, that's what we're talking about. When I say that 171, 94, 304, it's a specific part of our light spectrum that we can't see. It's extreme ultraviolet. Our eyes can't see it. So this tool actually sees it, and then they assign it a color. Okay, so when we're looking at this one, the stuff out there isn't actually yellow. Okay, it is whatever color, it is. But they use the extreme ultraviolet because it shows up. And that's why we do it. We get a better visual. So check this out up here. Let me go ahead and... Okay, I didn't notice something here that I wanted to point out. There seemed to be a little bit of a flash on the backside before that. So there could have been even a flare that's kind of disrupted the backside a little bit. So let's take a look. I'm gonna let this thing run and see if we can't see it. Just kind of look for the whole thing to brighten a little bit up here. Huh. Okay, maybe it didn't. Then that's why, that's why I slowed down here. Because I wanted to make sure I got that correct. So let's, so if you look at the top there, let's go ahead and zoom in some. Actually, let's zoom out just a touch. Okay. Okay. So, you look here on the bottom. See that, guys? I mean, that is just, it really was. It's impressive. That's what I'll say. And even on this one, guys, look, you can see it swirling here. See it all going back to the sun? It's a magnetic connection line. They call those solar vortexes, solar tornadoes. But again, those words can mislead you into thinking that they're actually wind, and it's not wind. Okay? It's highly charged particles, plasma, moving along that line. Why does it move along that line? Because it has a charge. That's what plasma is. It's a gas. It has a charge. So you have a positive and a negative. Positive attracts negative, right? So when one's the opposite, it goes that direction. They attract to each other. Okay? That's why, you know, our magnetic poles are moving closer to each other. You hear a lot of people talking about the North Pole, the magnetic North Pole moving a lot. But most people won't even venture out and say, hey, the South Pole's moving too, because it is. They're going to meet. Okay, that's what happens. That is a pole reversal. That's what happens. They meet, things reverse. And I'm not sure, when they do meet, that termination type event, I just wonder, could the positives still be in the same? I don't know. I need to research that out a little bit. Could the positives stay on the north or south and the negatives stay on the north or south, the same position it was before? I don't know. I don't know the answer to that. I just gave myself something to go look at. Anyway, so there you go. You see that? Right there. Right there. All right. So, I tell you what I'm going to do here. Let's pull up, let's go to Lasco C2 and see what we can find there. Okay, guys, I changed my mind a little bit there. I'm going to show you the NASA CME tracker, okay? And I'm going to show you this, and then I'm going to show you the NOAA, because I want you guys to be able to see what's going on here, okay? So what are we looking at right here? Well, top-down version on the left, side cut, which will give us north-south orientation, see if it's going north or south. And then over here is our magnetic, not our magnetic, but our orbital line around the sun stretched out in a straight line. So we need these three axes to be able to tell exactly what direction they're going. That's why they do this, okay? But notice over here. Do you guys see anything at all pop in this direction? Because Earth is right here. Now, when I was looking at that top eruption up there, it definitely did look like what? What did it look like? It definitely looked like it was going to come this direction some, right? So, a couple things here. It's definitely going off the back, in my opinion. At least that one. Now, the second one here, the timing is definitely right for that to be the southern eruption. Even though they look like they're like right next to each other, if you come over here and you look at the side cut, you see what's happening? Watch this magnetic line stretch out. You see that? So you got one kind of stretching it this way and the other one stretching it that way. Okay? So that's what I would say. Now, this IMF line here, that would be Earth, right? And I know it looks like that's the orange box here, but Earth is right underneath that. Okay? You just can't see the yellow ball on this one because they got that one there. But these are magnetic connection lines too, IMF lines, interplanetary magnetic connection lines. They're exactly what that says. They're traveling interplanetary inside our solar system. Our planet's here, and they're a magnetic connection line to the sun. Everything is connected to the sun. Everything. Satellites. If you were to, shoot up there like Superman, you would be too. Okay? So, just so you know. But if you look here, you see how you see both eruptions. And if you look at the last eruption here, it almost looks like we might catch a little of that right here. Okay, now it could be too far south. And most likely it is, because judging by this. So this is NASA's version of it. So let me take you over here and show you NOAA's version of it. Okay, as we do that though, I'm going to just show you while we're here what's going on with this. This is NOAA Space Weather Prediction Center, obviously, right? So what are you looking at here? Well, see this? That's that geomagnetic storm that hit a couple days ago. All right, we've already tailed off. Everything is very, very quiet geomagnetically. Okay? And now, again, we can't say 100% yet exactly what's going on here, but I don't think that these filaments are going to give us any issue. Okay, we may get a glancing blow from that southern one, it looks like, maybe. And I'll show you the Lasco C3 here in a second, because you can definitely see these two huge eruptions. This planet back here, that sometimes planetary alignments can affect the sun, guys. So with that one traveling on the backside there, because it came in from the right to the left. I have to go research and see what planet that is. But it does matter, but it doesn't. It might be Saturn. I think because Dex had texted me and asked me what, asked what that was over here on this imaging. And, I told him it was a planet. I just didn't know what planet it was. So he texted me back, and I think he went and looked. And I think he told me what he was seeing. I think it was Saturn. But, anytime we get planetary alignments back here that kind of line up as we see them come through and all that, it does increase the chances of the sun having a reaction, okay? Even as far out as those planets are. Especially like when you get like Jupiter lining up with things, okay? But so let's take a look at NASA's model. Now, again, these look to be not too much agreeing here, guys. And I could be looking at this wrong. If I'm looking at this wrong, I'm sorry, and I'll come back and correct myself. But I don't think I am. I'm not seeing anything going off the backside in this model at all. Okay? I do see it going north-south, but I'm not seeing anything coming off this direction, guys. So I don't know if this model was confused or what. But you do see two separate eruptions there. So in my opinion, this is what this model's trying to show us. So if you look at that, and then you go back and you look at the NASA one I just showed you guys, they're not agreeing whatsoever. As a matter of fact, NOAA's model, see this right here? See this uptick on the 28th? It's got one of those hitting us. So I'm inclined to say that this one might be a little bit off. That's all I'm saying. And again, that's why I nowcast, like I said before. I'm not going to try to forecast too far out at all because I simply just can't do it. I don't think anybody can really do it with very much accuracy. Okay? At least 5 days out. There's a lot of people out there to get real good at it, 2 days out, those kinds of things. But that's the same thing with real weather here on the planet, right? On Earth. Just go look at your local on the 8s on the Weather Channel and look 5 days out, and then 5 days later come back and compare, and you're going to see that most likely it didn't even come close, or it might have come close, but it definitely wasn't, 100% accurate. So I'm thinking that NOAA's probably going to come back and change this, okay? Because it does look like those things are going off the backside. I can't see much of it coming our way. And, yeah. So, I wanted to show you guys that. So, and as we go, we'll just scroll on down here. Well, you know what? I'll just show you Lasco C3. This is on Soho. This particular, satellite. Look at that, man. That was almost, oh, man. Guys, can you see how I'm saying? This is a zoomed out version of the Lasco C2. Oh, man. I honestly think that, yeah, I think this could have given us some issues if it came our way. And it's not. It's not coming our way. At least not directly, right? We might catch a glancing blower or something like that. But notice how fast this thing is moving, too. Okay, so let me pause it, and we'll show you. So there's the initial eruption at 1:47. Okay? And then 8 hours later, it's almost off the screen. Okay? Not even 8 hours. So, yeah. This thing's moving pretty quick. And that, and the CME Tracker, NASA over here. See how fast it's moving on this one too? Watch. Both of those are moving quick. Now, I'm wondering if something didn't happen kind of like in the middle of the backside and cause the polar regions of the sun to become unstable. So I'm not really sure when it comes to all that right away. But, you know, again, I'm going to nowcast for you guys. If something drastically changes today, I'll come back on and give you guys an update. I promise you. Okay? Because it won't be, it's not hard to do a 2-second, hey guys, it might even be a short. So please, you know, if you guys want to see that kind of stuff, hit that notification, because you won't, you know, you won't be up to date unless you do if I do it like a short update. I mean, you don't have to. I'm not trying to like, oh, hit my notification bell. But, you know, if you want to see it when I do these, you know, I guess what we call like a nowcast short update. And that's something else I was going to ask you guys too. If you guys would rather see some of that stuff too throughout the day, doing a little 1-minute short is really not all that difficult. Okay, it really doesn't take a whole lot of time to give you, just to go to one model, show you this, and then bounce out. Okay, it's not hard to do. It doesn't take up too much of my time or anything. I can do that from my phone. All right, I used to run this whole channel on my phone, just so everybody understands that. But anyway, this is you know, it's rocketing out there pretty good, guys. So let's go ahead and go over to ISWA again and check out the zoomed in version of Soho. All right, got you back over at ISWA, and what we're looking at, guys, is again Soho. It's about 1 million miles closer to the sun. This satellite is, okay, and what we're looking at is the Lasco C2 imaging on that observatory satellite. Okay, and again, it's from our perspective. It stays out about 1 million miles closer to the sun, but it orbits around the sun with us. And again, this one's very much like the Lord of the Rings and SDO. It keeps its eye on the sun. Now, they do move this from time to time. They do move the eye, and they can see things and all this and all that. But I want to show you the difference here, guys. This is the zoomed in version. Okay, the blue imaging I showed you a few minutes ago was the zoomed out Lasco C3. Okay, Lasco C2 and C3 are imaging on the satellite, guys. Okay, understand that. It's not the satellite itself. The satellite's called Soho. Okay, and you know, it's been really good at catching sun divers and things too. It's a good satellite. I hope we never lose that one. Well, we will eventually, but hopefully not for some time. Okay, so let's see what we can see. That there was another eruption that happened, I believe, yesterday. Yeah. Okay. Here's that one. Hold on 1 second here. Okay. Guys, you can tell how fast that's moving. I mean, it erupts right there. See the timestamp? And on Lasco C2, this thing is off the screen in roughly 2 to 3 hours. Okay, the speed and the amount of plasma there, if that was coming directly at us, I do think we could see some issues with that. I really, truly do. And again, you can see the hotter and colder parts of it, which typically will show you where it's the most dense. Okay, let's go ahead and zoom in a little bit so you guys get a better idea of what's going on there. Just yeah, sorry about that, guys. Okay, so yeah, right there. Yeah. So anyway, guys, I don't want to keep this any more longer than what it needs to be. But I am going to go ahead and pop off here, and we're going to go ahead and run with this one. This is anything else happens, guys, I promise you I will come back on and give you an update. You know, oftentimes we see this, and I've shown this before. You get an eruption on the sun, and then about 180 degrees on the other side, you get an eruption. And that's kind of what we've seen here, north south. Okay, it happens often, and it can destabilize the rest of the sun. It really does. We've seen filaments stretch from the back to the front, And when it does that, you know, we got to watch what's coming off the front for sure. So, yeah. So let me show you this one more time. Especially that one. Let's do this right there. Okay. So we'll see the top one right there. And that's a large area, guys. You can see how it busts in the middle. It really does. Okay. And then these, same thing. Notice, I do think they're related. Okay. I do think the top one, you know, if something destabilized that part, yeah. Okay. Or maybe the bottom here. I don't know. Well, something destabilized back there, and because both of them, bam. Now, did the top one destabilize the backside enough to cause the bottom one? Maybe. But does that really matter right now? It probably doesn't. And that's what I'm trying. But it is important to understand what's going on back there. Okay. Now you can see how we got other ones popping here and here. And then you got these dark shadows, guys, on the front side. You know, the name of the game right now, as I'm looking at the sun, is the filaments. Okay. And that's been the case a lot this sun cycle. Okay. So, yeah. I mean. So anyway, guys, I promise you that I will, if anything else happens, I'll be here. And I'll give you guys an update. My little nowcast. And I stole that term from Ryan Hall. He nowcasts the Weather Channel. Not the Weather Channel, but the weather here. Because he also recognizes that it's not perfect. Right? And, you know, our forecasting for real weather here on the planet. So, he calls it nowcasting also. He'll forecast. And he's really good at it too. But if something does change, he comes out and does real-time nowcasting. They chase tornadoes, the whole bit. It's an awesome channel. If you guys don't know who Ryan Hall is, I would be surprised to begin with. His channel's grown very, very big. I've been with Ryan Hall for, gosh, I bet I pointed you guys to him, most of you. I've been with him for a long time. And there's another, I think it's NNWW, his name is Andrew. I'll leave a link to both of those weather channels there in the description. But anyway, guys, so, yeah. Anything changes, I'll come out and give you guys a short update. And, yeah, so, God bless. Yahusha saves. And, yeah, you can drink this Kool-Aid.